Hello AP Physics 1, it's Mr. Ng, and here is number 41 out of your homework set. I chose this one because it goes over a lot of the stuff that we need to know, a lot of the stuff that we learned today, namely how to use the vectors on an incline. So let's dig right into it. We know that it's a 32-degree incline, and the acceleration is 0.3 meters per second squared, and the mass of the box is 15 kilograms. And what does it want? It wants, number one, the friction force, and number two, the coefficient of kinetic friction. Okay. Like always, I think the first thing we got to do is we got to draw a diagram and maybe put on our free body diagram. So this is 32 degrees. We know that. We have a box. And I'm going to call this f of x, right? I know many of us are used to f of a at x. It's just too many letters. And then opposing it is of the force of friction, which I'm going to call f of f. This is going to be our normal force, f of n. And this going down, not 180 of f of n, is mg. Good. You should have learned today that f of x is equal to mg sine theta. I know that looks really weird, but that's just the way it is. All right, just memorize it. I should have done a lesson already where I showed you why it's true, but this is mg sine theta. That means f of Newton is mg cosine theta. All right. That means f friction is basically the friction coefficient times mg cosine theta. Wow, we have all this stuff to work with. Just so you know, we actually don't even need this mass, but we do have a mass. It's 15.0 kilograms. Oh, 3 sig figs. Oh, the acceleration is equal to 0.30 meters per second squared. So it's actually 2 sig figs. Okay, so we have a lot of info. Let's do a sum of forces and see what we can figure out. So the sum of forces, and let's just do the forces going down, right? That's the only stuff that matters, and that's what this MA is about, right? This is the mass and acceleration sliding down this incline. So going down the incline, it's going to be the f of x, because that one is actually moving. That's the direction that it's moving, is in the direction of f of x, minus the force of friction, and that is equal to mass times acceleration. Seems easy enough. Part one, we want to solve for the friction force. So I'm just going to isolate friction force. That means the friction force is equal to m times a minus f of x, which is the force applied downwards, right, which is a component of gravity. I'm going to change all the signs so that the friction force is now equal to this little along the slope force minus mass times acceleration. And let's start filling this up. So I know that f of x is actually mg sine theta, mg sine theta minus m times a. And lo and behold, I know a mass, I know gravity. Sine theta is just sine 32. I can fill in all of these things. So the friction force is equal to 15 kilograms times 9.8 newtons times sine 32. Oh no, it's not newtons. This is meters per second squared, and that becomes a newton. Sorry about that, guys. Minus 32 minus 15 kilograms times 0.3 meters per second squared, and that becomes another newton. So when I fill this in, this becomes 73.4 newtons minus, oh no, this is, sorry, I skipped a step. This becomes 77.9 newtons minus 4.5 newtons. And then when you tally that together, you get 73.4 newtons. Or if you get it down to 2 sig figs, it's 73 newtons. Awesome. That is part one. Part one, the friction is equal to 73 newtons. And we also know that that is equal to the friction coefficient times mg cosine theta. I know it's weird that it's cosine theta, but it just is. Okay, just trust me on this. So we could just kind of solve for it. So let's divide both sides by mg cosine theta. So all cancels out. That means the kinetic friction coefficient is equal to 73 newtons divided by m is 15 times g, which is 9.8, times cosine of 32. So if you plug all of that in, I get 0.588, and the newtons cancel, so there's no unit here. And because it's 2 sig figs, I just get 0.59. That is the friction coefficient. So the biggest thing that you got to know is you got to know these equations. Going along the incline, mg sine theta, and then the normal force is mg cosine theta, meaning the force of friction is the friction coefficient times mg cosine theta. If you know those equations, very standard stuff here. Draw a free body diagram, do a sum of the forces, and everything should be copacetic. Thank you very much for watching. You're a wonderful student, and I treasure having you in my class.